First, you make a statement that really catches the audience attention by saying there will be in the near 2 decades 100 billion thinking inhabitants of the world. Can you explain who these inhabitants will be, where they come from, and how they will, communicate with one another? Like, where do we fit in this world of the next 2 decades? Again, it's not really far into the future.
So I'm not positing a huge human population boom. Let's say that the human population leveled out at something like 10 billion. What the claim is that for every human inhabitant, I think over the next 2 decades, we will see upwards of 10 artificial intelligences per human doing meaningful, productive things in the world. And to a large extent, kind of acting on their own, having a sense of agency.
Would you say my laptop here, right now on this table, could already be considered an inhabitant of the world, or not yet enough?
Not your laptop as such, but some of the software that might potentially be on your laptop could be. I wouldn't advocate that your laptop is an inhabitant. Your laptop is more like an apartment. There could be someone in there, It's the software, the thinking part, that I described as an inhabitant, because that's the part that is doing things that on its own, in a way. Over the last 2 years, AI has really grown into a very interesting shape, where increasingly more and more businesses like ourselves make use of AI to help us in our day-to-day tasks. In our workforce here at Auki, there are already AIs that are doing things and indirectly making decisions. Sure, there's always a human pushing the button, so to speak, in the end, saying like, yeah, this is the decision we're going with. But there are both design decisions and business decisions that have been very heavily inspired by conversations we've had together with AI. And we've trained different AIs internally to help us with different parts of our business. And now we have many different AIs at Auki with domain expertise with different parts of our business. And I think this trend will continue. And in a way, about half of our headcount at this company already is artificial intelligence. What's interesting is that, when it comes to our engineering, things like this, everything we do that's digital, it's very easy to invite AI to have a look at what we're doing. It's already in a format that an AI can understand. But when it comes to more physical things, both that we do and that our customers do, things like in retail rather than e-commerce, the physical world is not easily understood by an AI because the physical world is not digital. They don't have the opportunity to perceive or understand what's happening in the physical world. They can't look over our shoulder the same way.
So in such ways that we inhabit our bodies, but through our eyes, through our skin, our senses, we interact with the outside world. My computer here is also equipped with hardware that helps it interact with the outside world. In your vision of the tomorrow's 100 billion inhabitants of the world, what are the extra conditions that my computer will need to become fully operational?
So again, if we separate your computer from its inhabitant, like the AI living in your computer, we can look at what is the computer missing for the AI to use. And the main thing that it's missing if you want the AI to help you in the real world is that your computer knows almost nothing about this environment. Your computer doesn't know that it's on a table right now. It doesn't know that it's in a recording booth right now. It only has a microphone and a camera as its sensor organs and cannot reason very much about the physical world because of that. If you want an AI to really be able to come in and advise on lighting in this room and things like this, it needs to know what is the state of this room. So what's needed for AI to come out of the domain of the internet and come into the domain of the physical world is spatial computing. Spatial computing is the collected science of providing like sensory experiences to the machines, and the sense of proprioception, I think, is almost the most important sense here. It's not just seeing, because a camera can do that. It's not just hearing, because a microphone can do that. Being able to understand spatially what it is it's looking at, spatially what it is it's listening to. So I like to call it machine proprioception. Proprioception is the sense that we have that allows us to know, even with our eyes closed, that I have my hand in front of my face. That's the sense of proprioception. Machines don't have that.
How do you get there?
You get there with a lot of software and hardware engineering. So there are a lot of companies that are investing very, very heavily in building out spatial computing. Tesla is a fantastic spatial computing company. Apple is obviously a fantastic spatial computing company. Microsoft is a very powerful spatial computing company. If you look at the top 10 companies by market cap in the world, 7 of them, at least, have very serious spatial computing capabilities. The best AI we can imagine is an AI that doesn't only have to rely on its own sense organs like a camera, etc., but has the opportunity to incorporate sensor data from other cameras around your home, other cameras around your business, all kinds of sensors around the world. And to do that, you have to essentially do what's called spatial computing. What spatial computing is ultimately is teaching digital devices to understand the physical world. What makes the Apple Vision Pro a spatial computer is the fact that, it understands its position in the world, it understands its relationship to walls and floors and things like this. This is what makes it a spatial computer. And a very simple to understand claim is that physical spaces would require a spatially capable AI. Physical spaces require spatial AI, and spatial AI requires spatial computing. When I say that the population is going to grow to 100 billion thinking inhabitants, ultimately what I'm imagining is that there will be many artificial intelligences per capita solving productive, meaningful, creative tasks in the world to help build up civilization. So I chose the word inhabitant instead of citizen because I didn't want to necessarily imply any kind of political rights. That being said, I think humanity has a very bad track record of understanding who the moral patients are in the world. We haven't been good at seeing each other as moral patients often and seeing the full humanity of each other. For most of humanity, we struggled with things like slavery and other dehumanizing practices. And to this day, we still treat animals very poorly, better now than before. But we've really struggled with seeing animals as moral patients that are worthy of moral consideration. I'm not advocating that any particular AI today should be seen as a moral patient, but I think it would be very dangerous for us as a civilization not to keep it in the back of our mind that we might actually be creating something here that has moral consideration. I am hopeful, though, on a personal level, that maybe humanity realizing that AI can be a moral patient will also help us understand that there are animals out there that should be moral patients. Maybe that's wishful thinking on my part, that maybe we never understood that whales are people, but we will understand that once we've made a new person ourselves out of silicon, maybe. So there's an interesting moral question there, but what I meant by inhabitant is really that they are here and they are filling a productive role and making decisions. You don't have to believe in AGI or machine souls or anything like that to recognize that artificial intelligence is already being very productive contributors to civilization. So if we leave the word inhabitant aside for a while and just call them contributors, right? These contributors, we want these contributors to not be confined to the internet. We want the contributors to be able to join us in the physical world, because a lot of the work that we have to do and a lot of the things that we want to experience, etc., are here in the physical world. And there's a lot of attention being paid to OpenAI right now, of course, because they have built an AI on the internet that is very easy for consumers to understand. Like, it's very demoable, it provides real value right now. We use it a lot, it's fantastic. But I wouldn't assume that OpenAI is ahead of Apple or ahead of Tesla or ahead of Meta and these companies that have invested very heavily in the spatial computing, the machine proprioception part of this.
Why would someone think this though? Why it happens today on the internet that some people make this claim? What do you think? What do they look at when they say that?
I think they are just focusing on what is visible right now, right? And if you compare Siri to ChatGPT, it's very, very clear that ChatGPT is so much better than Siri. But Apple also has very powerful spatial computing. And once you want an AI to help you with the physical world, OpenAI has a lot of open source competition, but there's not that much open source competition to what Apple is doing with the spatial computing, right? So my hypothesis is that it's a lot easier for Apple to catch up with OpenAI in the dimension that OpenAI is working in than it is for OpenAI to catch up with Apple in the dimension that Apple has been working in. So Apple, Tesla, and Meta, and Microsoft, that have invested very heavily in spatial computing, might actually have a lead. To me, one of the most interesting companies in the world right now is Microsoft, because Microsoft has, both invested very heavily in spatial computing and very heavily even in OpenAI. If I had to bet on one company right now that would come out on top in the AI race, Microsoft seems like a pretty safe bet. But what Apple and Meta and Tesla are doing is also very, very interesting. I think last week there was a lot of mainstream media attention paid to the fact that Mark Zuckerberg and Meta are buying up a lot of hardware to train AI. And people treated this as a pivot, like, oh, he was going to build a metaverse, but now he's going to build AGI. He can't make up his mind. I don't think that's the correct analysis at all. I think that what Mark was building, in the hashtag metaverse era was the spatial computing capabilities that are a prerequisite both for everyone's understanding of the metaverse, but also a prerequisite for an artificial intelligence that can work with us in the physical world. I don't think Mark has pivoted at all. It's just about taking the next logical step. The next logical step is tying more cognition to the proprioception. Mark Gurman of Bloomberg a few weeks ago, basically implied that Apple is lagging behind in a pretty embarrassing way. And I think it's way too early to say that. Apple may very quickly leapfrog in terms of practical applications of AI, someone like OpenAI, because again, there are great open source alternatives to OpenAI, but there are no great open source alternatives for spatial computing. People are very protective of their spatial computing stacks, and I think for good reason. My personal hypothesis is that building out good spatial computing capabilities is one of the most valuable things that you can do this century, and by extension, one of the most valuable things that you could have done in the history of humanity. It's way too early to say that OpenAI is ahead of Tesla or Apple or Microsoft.
I keep on reading that one of the reasons why Apple in particular is lagging behind is because of its ethic with regards to a collection of data and privacy. And obviously OpenAI doesn't have this problem, or it doesn't have these guardrails. And that brings the question, how do we create a safer path for consumers? Can you actually first explain a bit more of what are the risks, the dangers, and how we create a safer path?
The danger is surveillance. And I think the danger is actually best understood from the spatial computing angle than from the AI angle, at least when it comes to privacy. So if we look at, for example, what Niantic has been building. Niantic is the company behind Pokemon Go, the most successful AR company in terms of a consumer product ever. They have built a very impressive positioning solution that helps a device understand where it is in the world better than a GPS does, right? Like it can recognize where you are on the street better than a GPS can recognize where you are on the street. So what they build, right, is they essentially use all this sensor data to create a digital twin of the world, like a digital replica of the world.
Now, how did Niantic achieve this without having a hardware themselves, without having created any device? Are they just collecting? How do they collect their data? Are we just talking about millions of cell phones or something else?
They get data from millions of cell phones, yeah. So a lot of people volunteered playing Pokemon Go to add data to this database. So essentially, the trade is if I send you what I'm looking at, you will send me where I am. Okay, that means literally the way that the device gets its position is through surveillance. So yeah, the data collection is coming from phones.
Solely.
Well, I don't know if they're buying data from other sources as well, but I mean, their competitive advantage, is that they get data from phones that are moving around in the world. One of the great things about a phone is that it's mobile. It moves around. It's not a webcam. It's not a surveillance camera. It moves around. And Google built up their API for this using Google Street View. They've had these cars driving around for more than a decade. I think more than 2 decades now even. Time flies. And they took billions, literally billions of photos taken by these cars, threw them into this machine learning tumble dryer and spat out a 3D copy of the road networks of over 80 countries. Like, it's incredibly impressive. But again, the way it works is tell Google what you're looking at, Google tells you where you are. So unless there is some big innovation in how positioning is handled, the future of spatial computing is that whatever provider you're using can see what you're seeing. And that's pretty scary. Because that also means, a not implausible, like quite plausible dystopian scenario is that Meta's AI or Google's AI can literally see through our eyes. 10 years from now, when instead of smartphones, we're all wearing AR glasses, they know what we're looking at. And not only do they know what we're looking at, they can see how our pupils respond to what we're looking at. So they know if we like what we see, if we're stressed by what we see, and they'll be able to measure and even modify our thoughts very powerfully. I think that the way that positioning is being solved in this centralized way, where we're sending all of our data to this vendor that we have to trust, is very dangerous. And one of the things that we're trying to do at Auki is to break this up so that, sure, you can use visual positioning, but you shouldn't have to send data about your home to us or to Google or anything. You should have the option, if you want to host it yourself at home, so that no one gets that data other than you.
And how do you make sure this method works as efficiently as if you were going to send it back to Meta or to Google? Like, how does your method work, and how do you create efficiency in a smaller network?
There are pros and cons. In some ways, it's easier for us because we're not trying to make a copy of the whole world. We're only making copies of smaller spaces. We call them domains, right? So our strategy is not to make one big map of the world. It's to make many private domains and an interoperable protocol that allows a device or a robot or an AI to move from domain to domain. Like a passport system that allows them to like, oh, I'm allowed to sign into this domain, I'm allowed to sign into that domain.
And that reminds me a little bit of during COVID when we were supposed to enter in a restaurant, scanning the QR code, eat there, come out, scan the QR code again. It's different because if you share your data with the government, a bigger system.
Yeah.
But that idea of getting into a space, scanning in and scanning out is
Yeah.
what you're advocating.
Yes. So instead of constantly being connected to this one world-spanning positioning system that has a coordinate system for the whole world, you're always moving between coordinate systems. Like the ultimate spatial computing challenge is the coordinate system, actually. Proprioception is a coordinate system problem. And the unfortunate thing about the physical world, if we don't live in a simulation, right? If we don't live in a simulation, there is no such thing as the coordinate system of the world. Every coordinate system is made by humans, it's relative to something, it's made up, it's a construct. And getting more than one device to agree on a coordinate system is like or even one device to agree with itself across time on a coordinate system is the fundamental challenge of spatial computing and positioning. And our approach is not make a coordinate system for the whole world, but to allow for the creation of smaller coordinate systems and the movement between coordinate systems. And we think that this is a more privacy-preserving vision where, if you visit the local grocery store, yes, maybe the local grocery store will be able to know what it is you're looking at. But then, what are they going to do with that information compared to what is Google going to do with knowing what you're looking at all the time? So that's the idea. Spread the risk, spread the surveillance. We don't have to give all of this power and all of this data in a winner-takes-all to one big company. I think that would be very dangerous. But I think these big companies, especially under a capitalist system with the pressures of delivering value to shareholders, etc., they're under a tremendous amount of pressure to actually become that monopoly of positioning. And one of the most chilling developments of recent years, as an industry insider, you might see this a little bit different. Amazon, the e-commerce company, bought iRobot, the company that makes the Roomba vacuum cleaning robot. Why would they do that? Well, to me, it's very obvious that they did that because they want to know what the inside of your house looks like, right? If they know what the inside of your house looks like, they can make better predictions about your socioeconomic status, about whether or not you can fit that couch that they want to recommend you, all of these things. These companies increasingly want sensor data from inside your home and from inside your places of business. And what we are trying to do is to say that, no, you can be the steward of your own data. You can have it. You don't have to give it to us. You can have it. We need to at least give people the option to self-host. Maybe they don't want to. Maybe it's just so much more convenient to let Google host everything. But if we don't give humanity the option to prevent the surveillance state, then the surveillance state is guaranteed, right? So it's better in my book to give humanity the option, and if humanity chooses the surveillance state, well then, okay, so be it, that's what we chose. But there should at least be a choice. I think that as a civilization, we are at a crossroads right now. We have to choose how spatial computing is going to be solved. Are we going to trust these big companies to do it, or are we going to try to do this in a decentralized way? Is it surveillance capitalism and tech oligarchy, or is it the free market and the people that can create this together? This is a very important question for us as a civilization moving forward. And this is the decade. This is the arena. Here's where we are.
Auki Labs. Share your vision.